Good morning, everybody who's joined in to our webinar today. Today, what we are covering is the EDW migration dilemma, which is one of the two, popular approaches, which is migrating as-is and total reengineering. And with our communication and conversation with our customers globally, we usually get this dilemma, of choosing the right approach between the two, and today we are going to uncover that. My name is Mohan Rajput, and I take care of marketing programs for Impetus Technologies. Before we begin, I'd like to introduce Impetus Technologies for those who don't know. Our mission, as you see on the screen right now, is enabling a unified, clear, and present view of your business, which is also known as creating a single source of truth for the organization. And that is what our mission is. Many of North America's most respected and well-known organizations trust us as a strategic big data partner. Our solutions include end-to-end from ingest to business access of data, and we've been in the industry for very long now and helping Fortune 500 companies achieve that. A quick look at the agenda today. Me and my colleagues will take you through what migration as a strategy is, what a total reengineering strategy is, what are the challenges and trade-offs there. From our experience perspective, what is a proven strategy that you can utilize in your migration if you are going through the same dilemma, and our automated assessment demo, which is something that enables the automated migration. And then there's an interactive way of doing things by having a Q&A. So I'd request everybody to use the chat panel to send in your questions as you want them, and then we can answer them, and my colleagues can answer them later in the webinar. Our first poll question is, what is the most efficient way to modernize your enterprise data warehouse, and what strategy are you using for your migration? Is it migration as is? Is it total reengineering? Is it a combination of both? Or is it none of the above? That we just display our poll right now. Before that, I'd like to introduce our panelists today. Reengineering Yadav has 21 years of experience in the software project engineering and management. Currently, he's managing the development of Impetus Workload Transformation, which helps enterprise to migrate their EDW and ETL workloads to a modern data platform. He also leads the India pre-sales for us. My second colleague is Sachneet Singh. Sachneet is a senior architect with the Innovation Labs at Impetus and has an extensive experience in big data cloud space. He's been working closely with a number of big enterprises and helping them in strategizing their EDW migration journey. So without further ado, I would like to pass the control on to Reengineering Yadav to take things forward for our webinar.
Thanks, Mohan. Good morning, everyone. Let me start by pulling a Forrester report. As per the Forrester report, the enterprise data warehouse has been the analytics platform for decades. But as the enterprises align their data initiatives with business goals and look out to monetize their data, there is a pressing need to modernize legacy platforms. In today's world, business users are demanding real-time analytics that can pull data across legacy platforms, social networking sites, and cloud sources. But there are limitations associated with current data warehousing platforms. And because of these limitations, these platforms are not able to fulfill the requirement of business users. Now, some of these limitations are like the existing EDW platforms cannot share data across heterogeneous repositories in a hybrid working environment. The platforms does not support ad hoc and dynamic analytics due to its use case specific architectural design. And the platform lacks self-service capabilities for business users to empower strategic decision making. Now, because of these limitations, enterprises are finding it difficult to get business insight in a timely manner therefore looking to modernize EDW platforms. There are two most common approaches to modernize EDW platforms, and these are the first one, migrating AsIs, and second, total reengineering. Let's discuss these two approaches in detail in next few slides. So starting with what is migrating AsIs. Now in this approach, you move the on-prem data warehouse workload to modern data platforms like Hadoop or cloud with no or minimum changes to the data model and or transformation logic. This model is also known as lift and shift because the application is lifted as is and moved or shifted to the modern data platform. In the next few slides, I'm going to talk about the benefits as well as the challenges associated with this particular approach. So let's start with benefits. Here are some of the key benefits associated with migrating AsIs approach. The first one, this approach enables enterprises to retain the existing business logic, process, and application behavior that has been actually built over the year on the modern data platform. The second benefit is this approach allows enterprises to use existing team to maintain the new system. The existing team will require minimum training to execute application on the new data platform. And this is very convenient for the people aspect of making newly migrated system a success. The third benefit is comparing the old and migrated system is quite convenient as there is a one-to-one mapping of the process flow, steps, and business logic. This also makes the transition to the newly migrated system quite easier. And the last benefit based on our experience is since it's a as-is migration, the business logic remains untouched. There is very less risk as compared to the re-engineering approach in which the complete system is rehauled. Now these are some of the benefits. Let's talk about the challenges, and let's see some of the business challenges first. Now one of the business challenges could be to align your EDW modernization initiatives with short and long-term business goals. For instance, one of the long-term goals could be to lay a strong foundation for an optimized data lake architecture. But since data warehouse is not assessed and workloads are not profiled, it's difficult to take measurable smart steps to achieve a stated aim or objective. And you may be focusing more on a short-term goal rather than long-term goal of achieving an optimized data lake architecture. Another challenge is directly related to cost and performance of the business logic in the target environment because the logic which is optimized for the EDW environment may not be performant on the modern data platform. And then the third challenge is there is no one-to-one mapping of the keywords, function, and clauses between the enterprise data warehouse and big data warehouse. Therefore, few of the logic which works actually on EDW environment cannot work as is on the BDW environment or modern data platform, and you need to actually figure it out some workaround so that you can achieve this functionality on the target platform. Lastly, since this is an as-is migration, you would be looking for technology set that helps to replicate the feature of EDW environment, thus have limited choices of technology stack and platform, because some of the features which are available on EDW side may not be available on modern data platform. So these are some of the business challenges. Let's talk about the operational challenges associated with this particular approach. Now the first operational challenge is technical debt. The technical debt could be the design and code debt. It could be the dormant data, tables, etc. The technical debt could be the result of choosing, for instance, a use case driven solution that temporarily addresses the problem but has very less visibility of either the overall landscape or future requirements. To handle this challenge and make sure that the right decision is taken, an extensive assessment of the current system is necessary to analyze the existing technical debt, and its current and future impact. Another operational challenge could be incompatibilities between source and target platform, owing to design principle, core capabilities, and more. And if I can give you a quick example, say for example, indexing as well as the ACID operation, which are available on the EDW environment, may not be available on, say, modern data platform. So you need to think about workaround, or you need to leave some of these features on the target platform. Another challenge is no insight about the current EDW. Since these EDWs are built over the period of time, even the existing team who are managing these data warehouses do not have enough insight about the architecture, data model, and some of the minute level detail which are indeed actually required for a transformation activity. Another challenge is like doing things manually or converting logic manually. Now, the manual conversion requires an end-to-end business understanding as well as technical know-how. And since these EDWs are built over the period of time, they might not be actually in a good shape. They might contain actually a lot of irrelevant information. And finding relevant information from these EDW scripts is a very tedious actually job, is a very time-consuming job. And it's not about just converting the business logic. You also need to think about how you are going to orchestrate the converted code, how you perform validation, and then what will happen to your parallel run, production deployment, and so on. So in a nutshell, the manual conversion, which most of the enterprises feel like is an easy step to go, is not actually that easy. And you tend to do actually a lot of rework and put a lot of time to move on to the modern data platform. Another challenge could be like meeting the SLA on the target platform. And since you do not have all the feature capability of the EDW environment on the target data platform, it is quite challenging to meet the performance SLA of the source environment on the target platform. So these are some of the challenges associated with this particular approach. So we talked about like the benefit as well as challenges of migrating AsIs approach. Now let's deep dive on the another approach, which is like total reengineering. And let me invite my colleague Sachneet Singh, who will walk us through with total reengineering. Over to you, Sachneet.
Thank you, Suren. And good morning, everyone. So let's talk about what is total reengineering. And while talking about total reengineering, I'll talk about what it actually means to re-engineer and re-architect. I'll also talk about some of the benefits of this approach, and I'll also talk about what are some of the challenges faced with this approach. So what is a complete re-engineering approach? A complete re-engineering is like re-architecting everything from top to bottom. It's about rethinking and rebuilding the entire framework for the data warehousing and data lifecycle management. Now this involves redeveloping, testing, validating the entire business logic that should precisely serve the purpose and meet the required SLAs. Now a whole lot of screening and analysis has to be done, and then everything has to be redone from scratch to end. So re-engineering is rebuilding, re-architecting everything from scratch. Now let's talk about some of the benefits of a re-engineering approach. The total re-engineering offers certain benefits since here a complete rehaul happens. And there is a lot of flexibility in terms of design, technical stack, platform, etc. Now, one of the biggest benefits of this approach is that it enables getting rid of the technical debt. The technical debt at design and code level can be taken care while designing, building, and coding the new system. The redundant components code can be cleaned up, merged as required. Also, the dormant tables, data, queries, code can be cleaned up. So one of the biggest benefits is getting rid of the technical debt. Another benefit is flexibility in terms of choosing the target platform. Now in an as-is approach, there are constraints like a SQL platform only. There could be feature constraints, functionality constraints, since the system is being moved as is. In a re-engineering approach, these constraints no more drive the decision to choose a platform, and thus the range of the technical stack and platforms to choose from widens, and the best can be chosen. Also, this approach enables custom implementation that are more optimized and best suited for the target platform, and is another big benefit. Now, since it's re-engineering, there is no constraint to do the things exactly the way they are in the source platform. The way things are on the source is no hindrance and obstruction to changes and customizations required to optimize and make the system perform better on the new platform. Also, finally, the enhancements to the current business logic can be accommodated and addressed very easily while rebuilding the complete system. So these are on a high level some of the benefits that come with a re-engineering approach. Now, at the same time, there are certain challenges as well. Let's talk about some of the business challenges. Now, a major underlying challenge with this approach is how to mitigate the risk of rebuilding the complete system again. Now, this includes how to decide upon which set of technologies and platforms will be able to handle the nuances of the existing data warehouse proficiently. Developing and establishing new reference architectures, several new design decisions need to be taken, and this may involve a lot of risk. Another challenge is stakeholders alignment. Now, the stakeholders from various groups need to align, taking this approach forward and redoing the whole thing from scratch to end. And thus convincing all the stakeholders and taking their alignment is another big challenge. Another challenge is choosing the right strategy, technology stack and platform. Now, there are a number of solutions and tools available in the market to choose from. The right platform offering the most scalable, adaptable, compliant, interoperable, and maintainable architecture is typically the most reliable and usable platforms. Now, working with our various Fortune 100 customers, we saw that even on the EDW side, they have plenty of tools deployed to process their jobs, perform their ETLs, for shell scripting, and so on and so forth. Now, while planning the migration exercise from EDW, the enterprise needs to plan the conversion of all of these ecosystem components and not just the workloads. So choosing the right platform is another big challenge. Another challenge is the training on the newer processes. Now, the training on the newer processes and technologies has to happen to mitigate the overall prevailing risks with respect to process documentation and so on. And this is another challenge. Now, whatever I discussed, these are on a pretty high level. But when we deep dive into what could be the challenge at a more final level, here are a few more. Security could be one challenge. Another, how can I decide if on-prem or cloud is better for my domain? Which cloud vendor to choose from? Which technology to choose that is best suited for my business use case? Who should be my deployment vendor? And how easy is it to scale on cloud? And on the similar lines, what about security, governance, as same as it is on EDW? So these are some of the business challenges with a total re-engineering approach. Now, along with business challenges, there are certain operational challenges as well. Let's talk about what they could be. Now, for this approach to be successful, the specification of the existing implementation has to be very clear, consistent, and verifiable. Now, one of the biggest operational challenges with this approach is the lack of a complete picture of EDW across different databases, storage formats, data formats, etc. Even the internal team who are managing the data warehouse don't have enough insights about the architecture, data model, and so on. And it usually takes a very long time to identify even the purpose of why a particular business logic was even written. Collecting appropriate information is too tedious and time consuming. Also, since a complete rehaul consumes, it consumes long cycles of code development, testing, and validation. Now, each phase is pretty complex, requires a lot of time, and has to be accomplished with utmost precision. The source code can turn into a big ball of mud if it is unorganized or does not possess clear roles or relationships. The code may have tight coupling and complex interdependencies on one another, and therefore may be very challenging to comprehend. The business logic that you have written over the years and perhaps decades have to be precisely translated into the big data compatible language.
Now leave aside the optimization part. For cost and performance, as-is translation alone takes a lot of skill and precision. And here we are talking about a complete re-engineering and rebuilding. Also, the code development and its validation requires skills of both source and target side. The personals with the right amount of skills, trained on niche technologies, with caliber to develop the big data compatible code, while understanding the business logic from the legacy side, can only succeed in true sense. Now technically, there isn't any one-to-one mapping of the keywords, functions and clauses between EDW and BDW. And thus, skill gap is one of another operational challenge. Now, all that I discussed on the operational challenges is on a pretty high level. But when we deep dive, there could be more at the finer level. For example, how many interfaces are currently used within my existing system for my consumers? For instance, let's say consumption tools, whether they use JDBC to access data, how Tableau connects, how BI reporting engines connect. And on the similar lines, what about the lineage once I migrate to BDW? So these are some of the challenges with a complete re-engineering approach. Let me pull up another extract from one of the Forrester reports, which talks about the next generation is EDW is the big data warehouse. And what they emphasize is that enterprises don't need to throw away their existing EDW platforms and their current investments. But at the same time, attaining new demands may require some re-architecture and some reinvestments. So where does this leave us? What is the best strategy? So let's hear what could be the better strategy. But before that, over to Mohan for the poll results.
Thanks, Ajit and Surendra. For the audience, we've got a mixed bag of responses, but what we see from our first poll question is majority of you are using a combination of the approach of the two popular approaches. And what we're going to do next, and I'm going to invite my colleague Surendra to take you through the combination and how efficiently you can utilize these two approaches and how how Impetus is helping Fortune 500 organizations around the world achieve that. Surendra, over to you.
Okay, thanks, Mohan. Now, before we deep dive and identify what is the right strategy for any organization to modernize EDW platform, let me walk you through with some of the factors that are basically helping us identify what is the right strategy. So future goals and objective of an organization is one of the important factors. The future goals, as aligned within the organization, may need the existing system to be migrated as is, or may require actually a complete rehaul. For example, in case the organization wants to move to cloud-based streaming applications from the on-prem batch system to achieve the future goal, the choice is obvious that a re-engineering is required because you are looking to change the complete business logic. You are moving from a batch system to a real-time system. Also, many a times a particular technology stack may be a key driver. For example, we have worked with organizations where a particular stack or platform was already chosen and all the migration and development have to be targeted for the chosen platform. In this case, a mix of both as is as well as re-engineering may be required. Another factor is technical debt. Now, a detailed analysis of the debt and its current and future impact needs to be considered before deciding on any strategy. If there is too much of technical debt on design and code side, which cannot be resolved without a complete rehaul, the choice is clear that you need to actually go with the total re-engineering. Now, another important factor is time to market. Now, as per our experience working with Fortune 100 companies, we have seen that as-is migration takes less time compared to total re-engineering effort. And another important factor is SLA and performance requirement. If the existing system has performance constraints due to the design and code limitations, it can only be resolved through re-architecting. Also, the target platform will be the basis of realizing all the SLA and performance requirements, and thus a chosen platform will also impact the decision based on whether an as-is migration can be supported on the platform or complete rehaul is required. Now, these are some of the important factors that we have collected based on our experience working with the customer. Now, let's talk about what is the right strategy then. And before we move on to the right strategy, let me quickly introduce you with Impetus Workload Transformation Solution. Now, Impetus Workload Transformation Solution helps enterprises migrate their legacy EDW and ETL platform on Hadoop and cloud environment. Now, Impetus Workload Transformation tool proposes the third approach, which is a fine balance between the two approaches. The tool overcomes the challenges of either of the approach and create a win-win situation for an end-to-end data warehouse modernization pursuit. Now, the tool, the Impetus Workload Transformation tool, helps attain both agility and reliability, making the existing workloads work best in the new environment. Now, I can share actually some of the example and try to relate some of the challenges that Sachneet and I talked about. So this tool provides an opportunity to migrate the already optimized workload as is. So that way, it addresses the need of retaining the business logic. If an enterprise has a proven business logic working for years and their team is comfortable, then this tool actually helps us migrate things as is. The tool also fine-tunes the expensive, resource-intensive, and poor-performing workload. Does it address the performance SLA-related concern or challenges? The tool archive or destroy the unimportant and unused workload so that it can address the technical debt-related challenge that Sachneet and I talked about. And last but not the least, end-to-end re-engineering of workload that contains very poor logic and are almost unusable. This way, like, we are addressing the need of re-engineering. So wherever you see like a as-is migration right fit because the business has a proven business logic, we can migrate it as is. And some of the as-is workload which requires re-architecting because of performance SLA or technical debt, we can actually we can fine-tune those workloads using re-engineering methods. So this is how exactly Workload Solution provides a proven strategy which is a mix of both migrating as-is as well as total re-engineering. Now, when I am explaining all this to you, the curiosity must have actually increased how exactly we are doing that. So let me invite Sachneet again to walk us through with how we are doing using this particular toolkit. Over to you, Sachneet.
Thank you, Suren. So let's talk about how we can approach the right decision and make the right decision. So the first step in the approach is to assess the existing implementation to identify first technical debt, unused, dormant, and duplicate data. Also identify what could be the possible performance optimization opportunities and what could be the target platform options. So the first important step is a complete end-to-end extensive assessment of the current EDW to extract insights that will help us make this decision. So that's step number one. And as Surendra just outlined, Workload Transformation offers an automated feature which can do an extensive end-to-end assessment of the current EDW and extract out all this information and insights which will be very helpful to make the right decision on choosing the right approach. After we are done with the assessment, the second step is to document the as-is state using the automated tool. Now, the tool features that workload transformation has to offer can also be used to reverse engineer the logic from code and data model where complete picture is not available. Also, it can help document the complete EDW system with details around its workloads, applications, users, and all. Also, as a next step, the insights extracted by the tool will also help analyze what could be the possible optimization opportunities for the current workloads. Completing the steps 2 and moving to the step 3 is the one where we make the decision between what can be migrated as is and what would need a complete re-engineering. Now, from our experience working with various enterprises, we have seen that it usually up to 80% as is, and 20% could be re-engineering. Now, this is where we use all the information provided by the automated assessment to make the right decision and decide what can be moved as is and what would need a re-engineering. Once we make a balanced decision using all the insights, the final step is to do the migration to the new platform into the new optimized schema. Now, it will include migrating the as-is code to the new platform, as well as re-engineering the complex and the bad code. Now, these are on a high level 4 steps that need to be undertaken to make the right decision, choose the right strategy, and migrate the EDW workloads to the BDW workloads. Now, having talked about the automated features and how workload transformation can help in each step, I would like to take you to a quick demo of workload transformation and show you how it enables automated assessment and migration. So let's quickly move to the demo. So just confirming, Mohan, please let me know once my screen loads up. Okay.
It is visible. Thank you.
Great. So what you see on your screen is the homepage of Workload Transformation Solution and Tool. Now, as the page itself says, it helps to automatically migrate big data to the modern data platforms on cloud or on-prem. And it does it through 4 steps. 1, assess, identify the right migration candidates automatically. 2nd, migrate and translate the legacy code and logic to cloud automatically. The 3rd step, validating, certify the migrated data, metadata, and other workloads. And finally, execute the translated scripts on any standard big data environment on cloud or on-prem. So workload transformation has automated features for the complete journey of EDW migration to modern data platforms, from assessment to migration and execution. So let me just quickly log in and show you the assessment part. So the landing page will show you some of the assessment summaries and recent assessments. But what I'd like to start with is showing you how easy it is to create an assessment using workload transformation and get a lot of insights that will help us make the right decision. All we have to do is select the input type. Since we are talking about EDWs, the workload transformation also supports ETLs and all, but I'll talk about EDW for now. You select EDW, and it gives you a choice to either connect to our DB connection, your EDW connection, or in case we have an offline query log, we can upload that query log, and workload transformation will analyze and extract out all those insights that would be critical to make the right decision and plan the migration journey. Now, having said that, this is all that needs to be done to create an assessment. Now, after we do the assessment, what kind of insights are available and how do they help make the right decision? Let me show you one of the EDW assessments that I already have and would like to share what kind of insights it has to present. So it has 3 tabs. I'll walk you through one by one. Now, there's a lot of information that workload transformation is able to extract and analyze, but I would like to talk about some important ones. Let me talk about the highlights first. Highlights will actually give you a complete inventory of your current EDW. Now, what workload transformation does is it creates a complete inventory, extracts insights about the workloads, their complexities, their dependencies, and categorizes them. Also, it performs a detailed analysis and presents facts and findings, and lastly makes recommendations. For example, on the highlight side, you will see what were the total number of queries. And not just that, how many were unique? What were the query types from select, update, delete, and all that? What are the query constructs used there? How many subqueries were there? Joins were there? Group bys were there? How many entities were there? Also, information around what was the CPU utilization, IO utilization, and also what are the most resource-consuming applications, users, files, and all. So a lot of insights to what is being run on the current EDW. And it's not just these facts that it presents. It also analyzes it in the background and presents complexities of the current workloads. Let me just quickly show you how it analyzes and presents the complexities and how does it help. For example, analyzing the current EDW workloads, workload transformation actually helps analyze how complex are the current workloads. For example, you will see for all the queries, there is a complexity matrix there. So there is a number that defines a complexity on a matrix on a scale of 1 to 10. Now, it uses its own algorithms to define what could be a more complex or what could be a more simple query. But the way it helps is, it helps to evaluate what could be the optimization opportunities for the modern data platforms. And would one of the workloads need a reengineering to be optimized on the target platform, or can it be readily done looking at the complexity? So this is one of the analyses and insights that workload transformation extracts that helps the decision. Another analysis that I would like to share is around parallelism. Now we are moving to a different platform, and we may be bound by SLAs and response times. Now, workload transformation also comes up with an analysis of the current workloads, recommending what part of the current workloads can be run in parallel. Now, how does this help? This helps in planning the workloads better for the modern platforms and making the right decision whether the optimizations or the optimizations can be done by running workloads in parallel and achieve the SLAs, or would they actually require a re-engineering or a re-architecture to meet the SLAs? So this is another recommendation and analysis that workload transformation presents. The third part that I would like to quickly talk about are the recommendations. Now, there are a lot of recommendations that it makes, but I would like to quickly talk about two recommendations here. One, you'll see something called used entities and unused entities. So unused entities is the one that workload transformation has identified that these entities are no more used anywhere with the workloads. So that means this is a technical debt. Identifying the technical debt will help us make sure we don't really take these unused entities to the new platform. So we are able to identify the technical debt here. Another thing that I would like to point out here is the recommendations workload transformation makes for the entities. For example, you'll see a recommendation for partition by and cluster by. Now, these are optimization recommendations that workload transformation makes for the target platform. Now, these optimizations can be used to make sure that the workloads, once migrated to the modern platform on cloud or on-prem, meet the SLAs that are required. Now, these are some of the recommendations, highlights that the assessment, the workload transformation automated assessment presents and helps make the right decision on what can be migrated as is and what would need a re-engineering. Now, once we are done with the assessment, how do we plan our journey to the big data platform on cloud or on-prem? How do we transform the workloads as is, validate them, and execute on the modern platform? For that, workload transformation has rich features for automated transformation, validation, and execution. Let me just quickly open one of the pipelines to just quickly show you how this migration happens. I'll just quickly talk about the stages because there's a lot that happens in the background, but what I would like to highlight is we can build different stages from migration to data validation to workload translation, then its validation, and finally its execution on the modern data platforms. So workload transformation also offers and enables automated translation to the modern data platforms on-prem and on cloud. So this is all that I had from the demo perspective. Over to you, Mohan.
Thank you, Sachdeep. Now, all we've discussed is the two, major approaches that people use, and I think the audience is aligned and has been using a combination of both. I hope the content of the webinar really helped you, get some insight into what Impetus does and what value Impetus provides. What we're going to do next is go into the interactive, session of our webinar, which is very, exciting for us. So that, and we've got very exciting questions also coming in. One of the questions that came in is, what is the validation strategy that Impetus uses after, so Surendra, would you like to take that one?
Sure, Mohan. So regarding validation strategy, if the audience actually can see the block labeled as validate, can give you actually some sense as what we are doing as part of the validation strategy. So there are two types of validation that we support. One we call as a basic level validation. So the basic level validation is like we check for count, some of the aggregate function like sum, min, max. So as part of the basic validation, we perform these functions and match actually the count as well as the sum to ensure that the first level of validation is done when you migrate your data as well as logic. The other type of validation that we do is like we refer it as an advanced level validation. And as part of the advanced level validation, we do actually two types of things. One, we do a query level validation where we invite user to provide a customized query based on their business needs and use that query on source and target environment so that we can match actually the data between source and target. The other type of validation is like doing actually a cell-by-cell validation, which is done using two steps. One, we take the baseline data from the source, migrate it on the target environment, and use cell-by-cell validation to ensure that the data migration is successful. Now, once the data migration is successful, then we use actually the logic which is part of, say, the EDW script, which could be in form of shell script, if it is a Teradata BTEC script, maybe the store procedure, and so on. So what we do is like we take these scripts and feed it into the system. System provides the converted code. So what we do is like we fire the source files on the source environment and create a processed data. Similarly, the converted code is fired on the target environment, and then we get actually the processed data on the target environment. We use both processed data at source and target and perform a cell-by-cell validation to ensure that each and every record is migrated properly or converted properly. That way we verify that the functionality or the logic has been converted properly. So this is the validation strategy that we are using while migrating EDW on the BDW environment.
Thanks, Surendra. Our next question is, what is the degree of automation that you've spoken about achievable by the tool? Surendra, would you like to take that one too?
Sure. So we do actually migration of EDW and ETL both. And when I say like EDW, like we perform a migration of Teradata, Netezza, DB2, SQL Server, Greenplum, Vertica. Similarly, on the ETL side, we perform a migration of Informatica, Ab initio, DataStage. So these are some of the ETL that we support today. Now, we provide 70 to 90% of auto conversion of all these workloads on the target platform. Now, the target platform could be like your Hadoop or cloud. So 70 to 90% is the auto conversion, and then the remaining, we use our expertise, our services to convert the remaining part. That way, we provide a complete 100% converted code which is compatible to the target environment.
Thanks, Surendra, and we've got more questions coming in. The next one is, how do you perform data ingestion into GCP BigQuery? Sachin?
Yeah, sure, Mohan. So the ingestion to the GCP, so we have different features available for data ingestion, since in workload transformation, we support different and various target platforms. So for GCP as well, we have an ingestion feature available, which is a Spark-based feature. Now, it depends on the kind of source that we are reading from. For example, we are reading from a Teradata, Netezza, Oracle, or some other data warehouse. So we have a Spark-based ingestion feature and a strategy wherein we break the files from EDW into smaller chunks and push them to GCP through our Spark-based ingestion engine. So we have this strategy implemented with workload transformation to support GCP.
Okay. Thanks, Sachin. That was insightful. To our audience today, we thank you for joining in to the webinar today. That is all the time that we have, but we have some other questions also, which we'll be following up upon on an email. If you have any other questions, you can always send them in at inquiry@impetus.com. Do visit our website for more details on our solution. And this brings us to the close of our webinar. Thank you for joining in. Thank you.